going to study something about hybridization. And this time around, I'm going to give you the short form of how to find a hybridization of a given molecule, its shape and bond angle. So for me to start, we know that hybridization, it is the mixing of different orbitals of the same atom to yield new and hybrid orbital called what? Hybrid orbital. So here, hybridization in hybridization, what we know is that we consider the number of atoms bonding to the central atom and the electron pairs. So here, number of atoms and the type of hybridization. When the number of bonded atom and the lone pair is 2, the type of hybridization is sp hybridization with linear shape and bond angle of 180 degrees. When the number of atoms plus the number of lone pairs in a given molecule is 3, it will undergo sp2 hybridization with the shape of trigonal planar and bond angle of 120 degrees. When the number of bonding atom is 4, it follows like that: sp3 tetrahedral shape and the angle is 109.5 degrees. When the number of bonding atom and the lone pair is 5, we have sp3d. The shape is trigonal by pyramidal. So let's consider the number of atoms with 2, 3, 4, and 5 first. So we will look at the following example to see how to use a shorthand form or shortcut to predict the shape of a given molecule as well as its hybridization. So let's look at these examples. CH4, NH3, H2O, xenon, oxygen, and we have xenon 2F4, like this. So here, let's consider the CH4 first. If you want to know the shortcut for finding the type of hybridization this molecule will undergo and its shape, it is just the number of bonded atoms plus the number of electron pair. If you consider carbon is having 4 valence electrons and it has shared a bond with 4 atoms of hydrogen, Hence, you write your four atoms of hydrogen. If you consider here, it has shared bond with this hydrogen, this hydrogen, this hydrogen, and this one too. So it left with 0 lone pair. Hence, 4 plus 0 is what? 4. Hence, it has undergone sp3 hybridization. Let's consider NH3. If you consider NH3, the N, which is nitrogen, is the central atom, and it has 5 outermost electrons, and it has shared a bond with 3 hydrogens. So it's left with only 1 lone pair, only one lone pair of electron, only 1 lone pair. So here, 3 atoms plus 1 lone pair will give us 4. Hence, NH3 will undergo sp3 hybridization because the number of atom plus the lone pair gave us a number of total of 4, which is sp3 hybridization. But here, since there is a presence of lone pair of electrons, the shape is not tetrahedral. The lone pair will repair the bond between the hydrogen and the nitrogen for it to decrease the angle, for it to become something like this. It will decrease the angle from 109.5 to 107 degrees, and the shape is trigonal pyramidal. Trigonal pyramidal. Okay, let's consider xenon with 3 oxygen sharing a bond with it. So here, xenon is part of the noble gases, so it has a valence electron of 8. There is 3 oxygen. Oxygen undergoes what? Double bond. Hence, this oxygen will share a double bond with this lone pair, double bond with this lone pair, and double bond with this lone pair. It left with only what? 1 lone pair. How many atoms? 3. So 3 plus what? 1. It too will undergo sp3 hybridization. Okay, let's consider water. Water, the central atom is oxygen. You know that oxygen is having 6 valence electrons. So the oxygen will share a bond with this hydrogen as well as this. But at normal circumstance, it must appear like this. So that these 2 lone pair will repair the bond between the hydrogen bond between the oxygen and the hydrogen for it to undergo a bent shape. And here there is 2 atoms plus 2 lone pairs. 2 plus 2 is what? 4. Hence, it too will undergo sp3 hybridization. Water undergo sp3 hybridization, but the shape is bent shape due to the repulsion caused by the electron pair. Okay, so that is water. Let's consider the last one, which is xenon bonding to 1 mole of oxygen plus 4 moles of what? Fluorine. It too, we know that the xenon belongs to the noble gas. Hence, it has 8 outermost electrons. So 2 of the outermost electrons will share a bond with this oxygen. 2. And it's left with what? 6 electrons. The 6 will use 4 to share a bond with fluorine, and it will left with how many? 2. And the 2 is a lone pair, hence it becomes what? 1 lone pair. So there is 1 lone pair plus 1 oxygen plus 4 fluorine. 1, 2, 3, 4, 5. plus what? Another one lone pair, which is what? Make it 6. Hence, is 6. And the 6 is sp3d2 hybridization. And the shape is octahedral. So this is what we have studied in this video concerning the shortcuts used in hybridization and molecular geometry. See you next time for a new topic. Thank you.